Cool. All right. That's working. So can everyone hear me?
We can hear you, Fraser.
All right, awesome. Okay. Well, so hi, everybody, and welcome to the Weekly Space Hangout for May 3rd, 2012. Now with our spiffy new intro graphic, thanks to Pamela. So today we're going to be talking about the Shuttle Retirement, Asteroid Mining, finally, killer black holes, a new mission to Jupiter, the problems with SpaceX, and brown dwarfs. And we've got some new faces here this week, so I want to introduce them first, and I'm just going to start in no particular order except sort of left to right for me. So we have Amy Shira Teitel. I hope I pronounced that right. I forgot to ask you beforehand.
Teitel, like a book.
Teitel. Amy Shira Teitel, who is a blogger at Vintage Space and has done some work for Universe Today and Discovery Space in the past. Amy. And we've got Sawyer Rosenstein, who runs the Talking Space podcast and has probably recorded about 1 million episodes.
Little over 100, but close.
A little over 100, yeah. But has got a great podcast, and if you haven't checked it out, I highly recommend you go and check out the Talking Space podcast. And of course, new last week we've got Jason Major, who is a blogger for Lights in the Dark and has done some work on Universe Today and Discovery Space. Everyone seems to work for Discovery Space. And we've got, of course, Alan Boyle from MSNBC's Cosmic Log. We've got Nicole Gugliucci, the noisy astronomer, and perhaps a new doctor now, Dr. Nicole Gugliucci.
Okay.
That is awesome. So, and is it official? Are you?
I have to finish getting the paperwork signed and do all the edits, but official enough.
Other than that, if we called you Dr. Nicole Gugliucci, that would be acceptable.
Yeah.
Oh, that's fantastic. Congratulations, Nicole.
Thank you.
And of course, last but not least, Dr. Ian O'Neill from Discovery Space.
Hi.
All right, and so let's get cracking. So why don't we'll go easy on the new people this week so they can sort of see how it goes. And I thought I would just start with the story that I really wanted to get to last week, and we actually ended up talking about it for quite a bit, which is the announcement from various entrepreneurs about their plans to try and mine asteroids. And Alan, you've been doing a lot of work on this story, both last week and this week, and we'll probably continue to be all over it for the next decades. So where are we at with this right now?
I'll tell you where I was at this morning. I was driving by the headquarters of Planetary Resources. It's in Bellevue, Washington, and just happens to be down the street from where I live. So on the way to work, I stopped by there. It's a very unassuming little business park type office. You can't really see too much of what's going on, but they do have a big garage or workshop, and I actually went by there last night, and they had the lights on there too. So it's interesting to have a rocket company in basically my backyard. So I'm looking forward to more about that. If you haven't been keeping on top of this, Planetary Resources was known as Arcid Astronautics, and in fact that's the sign on the door on the office is Arcid Astronautics. And it's kind of a stealth operation, but the long-range plan is to go out there, find an asteroid that has water that might be used by future spaceships, or has platinum or other precious metals that could be brought back down to Earth for profit and make trillions of dollars. That's the long-range plan. The short-range plan is to build a new generation of low-cost space telescopes that can be used to hunt for asteroids, or even sold to people who might have a few $1 million and would like to have their own space telescope, or, if you turn it the other way, an Earth-observing satellite. So that was the big splash, and the reason why people are taking this seriously is because they've got so many high-profile backers, investors like Larry Page and Eric Schmidt from Google, Charles Simonyi, who was an executive at Microsoft and is now at the head of a company called Intentional Software, and actually lives in this Bellevue area, and that's one of the reasons why they're headquartered in Bellevue. And James Cameron is an advisor for this effort. So you've got the guy from Avatar helping these people figure out how to actually make avatar reality one of these days. So that's the top line on what's going on, but it'll take a couple years for them actually to put some hardware into space. They're building that hardware, the first generation of space telescopes, right now down the street from where I live.
Now, it feels to me a bit like we're being, I don't know, it feels like we're in some kind of dream, and we're going to be waking up any second, and then it's going to be back to, no, we're actually, not going anywhere, and we're going around the Earth. So how do you like their chances? I mean, it feels like a science fiction movie or a book.
No, I know how you feel, and it's kind of the same way with space tourism, where at first everyone thought, okay, in 2 years we're going to be flying into space, everybody can buy a ride into space, and we were thinking that way maybe 8 years ago, and it's still about 2 years away. Same thing could happen with planetary resources. They're thinking a lot longer range, but they have the money to keep doing this for quite a long time if they want to. I know other folks have written about this, like Ian, and I think we're kind of on the same page that the short-term plan sounds good. The long-range plan, of course, is always going to be a lot iffier.
Yeah. Like I said, it feels like a dream come true, and then we've had those expectations blown so many times that I don't know. I kind of feel. I think you hit it exactly right on the head, which was that when we had the launch of the X Prize, boom! It was you could see that a small group could put together a spacecraft, get it up to the edge of space and back twice within a week, carrying passengers. Where's my flying car? And,
I think, Fraser, you hit the nail on the head there, and that's really my main concern about this whole asteroid mining idea. And the principle is great. I mean, I wrote a lengthy opinion piece that drew quite a lot of anger. I didn't know that asteroid mining was so precious to so many people. But yeah, I got called every name under the sun for what I wrote. But
I'm getting mad just listening to you.
Kick him off.
Piss people off.
Heretic.
Yeah, and basically, and in principle, I love the idea. And as was said in the Planetary Resources Conference, what I would consider a conservative estimate that there are $50 billion worth of precious metals in like a 50-meter wide asteroid, and that's only half the story. I mean, everybody talks about gold and platinum and precious metals and all these rare minerals we can't find on Earth, or at least running out of on Earth.
Like unobtainium?
Unobtainium is there too.
Yeah,
huge quantities you wouldn't believe. That's why we need to go into space tomorrow.
That's why we need James Cameron to find
he's the guy in the know. There's a reason for him to be there. I'll tell you. There's a bit of conspiracy theory there. But so the idea is sound, and and also what I probably find more exciting than asteroid mining itself is actually extracting water from these asteroids, because we know that asteroids contain water, certain types of asteroids do. So if we can find a target that's water rich, perhaps we could send a refinery there that can extract the water and purify it, and just have these orbital fuel depots for the future of spaceflight and for future human colonies elsewhere in the solar system. I mean, it's a fantastic idea. But my biggest criticism and my problem is that what Fraser said, the whole space tourism thing, that's been bandied around for as long as I can remember. I mean, I remember doing a presentation on it when I was like 15. And back then, I thought it would be, this is a thing for tomorrow. The timeline was very imminent. And I found that now we're still waiting for space tourism to happen. I mean, of course, we've had millionaires going to the International Space Station. I wouldn't necessarily call that space tourism in a mainstream sense. But I get the feeling that people are kind of getting a bit tired of the whole space tourism thing. I mean, it's still exciting. I'm sure that it will, excite interest when we start seeing the first celebrities going into space. But ultimately, I think people are, kind of getting bored of it. And unfortunately, with asteroid mining, it's such a far-off goal, and there's no real business plan to it. I mean, of course, in the short term, as Alan said, building observatories, building, the inevitable spin-off technologies that can be sold and developed. But ultimately, refining materials on an asteroid is a massive unknown. How in the hell do you do it? And it's gonna need massive amounts of funding to do. I mean, refining materials on Earth is hard enough. and expensive enough. These refineries cost billions to build. And so this new endeavor to refine asteroid material just seems really far-fetched and certainly worthy of further research. But as for putting a business plan around it and getting investors at this early stage, I just think it's just setting themselves up for a very quick fall, which is unfortunate.
Ian, I saw the video.
Oh yeah, go ahead, Jason.
I saw the video, and it looks pretty simple. They look for the asteroid. There it is. They put the Kevlar baggie around it. The little spacecraft go up and down, and then you get a whole bunch of really valuable material that you can start building spaceships with and go to other galaxies. I don't see what's so hard about that.
Right. Interesting you say, because it was like that they're targeting near Earth objects. So basically, these asteroids that fling past the Earth and are very, very scary. So the obvious application for asteroid mining would be asteroid impact mitigation. So we could, perhaps steer these asteroids into Earth orbit and then mine them. So we've not only got a business, we've also got a means of saving humanity, which I found really, really cool. The only problem is we haven't got the technology to do this, and that we're assuming that we're going to have this magical technology in the future because there's some business interest behind it, there's some motivation to develop this technology. It doesn't mean we're going to have this technology. And I get the feeling that everybody kind of pins their hopes on nanotechnology to do the refining, to actually digest these asteroids. And bearing in mind, to actually extract all these minerals from an asteroid, you need to digest the whole thing. I mean, it's not just going in there and digging and finding like a clump of metal in there that we can just pull out. The entire asteroid needs to be refined and pulled apart. And to do that, it's going to expend a lot of energy, massive amount of investment. If you wanted to steer these things into Earth orbit to make it a little bit easier so it's closer to home, I wouldn't like to make a mistake. So there's just so many unknowns I think that aren't considered. And I'm not saying it's a bad idea, I'm just saying it's not an idea for the near future.
Yeah, I mean, I think it's important to understand that we absolutely want them to continue investigating and doing this. Go full steam ahead, don't stop, damn the costs. But don't give them a hard time if it takes a lot longer than anyone was expecting. And absolutely. I guess that's what I take out of this is a lot of people say, we've got so many problems on Earth, why should we go into space, et cetera, et cetera, et cetera. And just like, no, we should absolutely do this. Just don't pin your hopes and feel frustrated if it takes 50 years to figure this out.
There's one other thing I wanted to mention is that another revenue source is selling the data from the venture itself, and that's one of the reasons why they say that Planetary Resources is already cash flow positive, is because they're doing data deals with NASA. For example, they're trying to develop a high-tech laser communication, navigation, imaging system, and so NASA is interested in that. And so once again, you're kind of getting into NASA as a future market for commercial ventures like this. And so, if it's sustainable, if they feel as if they're getting enough money coming in to keep it going, even if they never get to an asteroid, it's probably going to do a lot of useful work for space exploration.
Yeah, and so where, Ian, can people send their hate mail? Ian
Discovery News.
Discovery News.
Discovery News and spammers.
All right,
there you go.
Well, so why don't we
please spam us.
Dear spammers, yeah, okay. So why don't we move on then to a kind of related story, which is some of the problems that SpaceX has been having, and this is going to be Amy Shira Teitel. So Amy, what have you got for us?
I can't really speak to the problems that they've been having, but I can speak to the problems and what it might do for SpaceX and what it might do for NASA. So if anyone has the technical details of the tests and the problems, please jump in. So SpaceX has been delayed again for launch. They were supposed to originally launch in February. I think February 7th was the first date, and they've been pushed back and back and back for technical problems and weather. And part of the problem is that SpaceX only has a launch window every 3 days because of the orbital pattern of the ISS and the way it takes them to reset and all this stuff. So I haven't seen yet that they've made a formal statement saying that the launch for May 7th has been canceled. They're still saying it's unlikely. So I'm just waiting for that to be canceled. But if it does, the next launch opportunity would then be on the 10th of May. If it's on the 10th of May, they have no backup opportunities for launch because there's a Soyuz going up to the ISS on the 14th. So this would put them in the bad situation of weather or technical delays. They would be stuck waiting it out. If they can't dock with the ISS, they won't have a chance to reset and try again. So that's another issue. The odds are, I would say, they're probably going to wait until at least the 19th or the 21st of May to do that launch, because this is a huge mission for them. This is their COTS 2 and COTS 3. So maneuvering very close into the station to sort of prove that they can do it, and then getting close enough to grapple the pod and pull it in. So it's worth waiting for, I would say. I don't think it's worth rushing into, but if it does, not to mention if it fails, this would not only be really embarrassing, it would be really bad. NASA's really hoping that they're going to pick up the slack for doing all the low Earth orbital stuff.
I mean, I think there's a real expectation. I mean, a lot of people are really grumpy and sad about the loss of the space shuttle, which Sawyer's going to be talking about in a second. As you know, as that all wraps up, and what everyone says is, okay, and now we have no way to get to space. We're going to have to rely on the Russians to get to space. But SpaceX has been filling in that gap and moving really quickly to get themselves to a point where they can fill in a lot of the resupply with the International Space Station, and even, you know, provide some other support for other missions, and, you know, possibly even human-rated stuff down the road. So do you think that there's like extra pressure on them at this point to take over that mantle?
A little bit, to prove that they're sticking to schedule. I think the date that NASA wants to be able to start using them for cargo supply missions is 2015, and I haven't seen if there's a change to that at all. So I think there is some pressure to make it known that they can do this and that they are on target, because the longer their delays keep stacking up, and if they do fail with any of these missions, it's just going to put, people are going to start getting really angry that we're relying more and more on the Russian Soyuz to get up into orbit. And it's going to make people hate NASA more, and it's just going to spiral from there. People already hate NASA these days.
Who hates NASA? Where?
So I think there is a lot of pressure for it to go well. I mean, there's a lot riding on it, but I don't know. I mean, it's unclear. I don't understand. I haven't gone into the technicalities of what actually went wrong, but you know, it could just be really bad if it does delay enough that, you know, 2, 3, 4 years, that NASA, if the SLS does get built, if that magically doesn't disappear, that this massive rocket will be limited to low Earth orbit, which would be so sad.
Yeah.
The way I see it, I was just going to say the way that I see it, it's not that big of a deal. I know that for people who are looking forward to this launch, which would be the first commercial visit of after the International Space Station, you know, everyone is anxious to have this happen. It's not really a problem. It's not a glitch that is holding back the launch schedule. It's that SpaceX is kind of tweaking the software code for its flight computer management system, and all those changes have to be verified by NASA. And so every time SpaceX makes a little change in the code, NASA has to sign off on it. And so they made some changes recently, and NASA feels like it wants to have more time to verify that everything is going to work right with that revised code. And so you're kind of getting into a situation where you've got the software programmers saying, okay, this is great, we fixed it, and NASA saying, well, we want to check to make sure everything, and there's a little bit of push-pull there. And so it's not like a problem came up that had to be fixed. It's just that they need to have a code freeze, I guess, at some point, and say, okay, this is it, we're going to go forward with it. And the static fire test that they had earlier this week was successful, and they didn't see any problem with it. They did have that problem, why they had to restart the countdown, is that they had one of the limits set too high for the computer system. And so that's the sort of thing that enters in, is a little software glitch. They're so dependent on software and simulation of how this flight is going to go that you've got a lot of pushing and pulling in advance of the launch, and hopefully the launch itself will come off pretty well. You know, they might have to delay because of the Soyuz launch of a new crew to the space station. They might have to kind of go after. It's, you know, in the grand scheme of things, it might not be that big of a deal. But every time you hear delay, you think, oh, there's something wrong with the system, and maybe the reality is that it's not as wrong as people might think based on the information they're getting.
So why don't we move on? I know, Nicole, you've got a schedule, you've got to meet. So why don't we'll switch over to you for a second, and that way you can get your story out of the way, and then you can stick around for as long as you can.
Okay.
And so, Nicole, you're going to talk to us about a killer black hole. Not for this
Yes.
space exploration stuff. Let's talk about some astrophysics.
Let's go. We're really far away now. You may have seen the headlines about a homicidal black hole. And I've mentioned this before, that I think black holes get a bad rap that they don't really deserve. I mean, they're just sitting in space, pulling things in like they're supposed to. So this story is about a supermassive black hole. It's estimated to be a few million solar masses, maybe 4 million solar masses. So several million times the mass of our sun is a really huge object, but on the scale of black holes in the centers of galaxies, it's not that big. And in fact, it's in a quiet galaxy. About 10% of these black holes are actively pulling material onto them, or accreting material, we say. So that makes them really bright and active, and they're called AGN, or active galactic nuclei. This one isn't active at all. It's quiet, so it's like 90% of the supermassive black holes out there. And during a survey, they noticed this spike, this increase in optical light and UV light coming from the center of this galaxy, and it matches the signal of a single star being pulled apart and ripped apart and eaten by this black hole. So this is the first time we've seen this kind of direct evidence. We've figured out, the team figured out what kind of star it was. It was a red giant. It had come close to the black hole before, probably, so it had most of its hydrogen atmosphere had been ripped off, and it was mostly just the helium core left. It's this helium core of a red giant gets too close to the supermassive black hole, and it just gets, like, the gravity rips it apart. And about half the material falls into the black hole and is never ever seen again, and half of it gets ejected out, usually in some kind of jet. And so this team from Johns Hopkins, I think, saw this signal, said, this is a single star getting ripped apart, and this is the first time we've ever seen it, which is pretty cool.
Well, I think we've had situations in the past where Emily shows up in the middle of our hangout. Hey, Emily, how's it going? Emily Lakdawalla from the Planetary Society.
Sorry I'm so late. I lost track of time.
All right, it's okay. We'll talk about what you're going to talk about in a second. But with Nicole, I've done stories in the past where scientists have detected that, like, almost like a single asteroid's worth of material has fallen into the supermassive black hole at the center of the Milky Way. Like why are fairly small amounts of material so easy to detect? It'd be amazing when you think about the consumption that's going on in some of these supermassive black holes and how far away these galaxies are. Why are we able to detect this kind of stuff with such precision?
Right. It's a time varying signal, right? So that you see this brighten and dim, so okay, something funny is going on there. And that tells, so it's that time domain detection, and also, like you said, the energy of a star being ripped apart. So all the potential energy of the gravity holding the star together starts to be released as part of it falls into the black hole, part of it gets ejected. And so that's a lot of energy. I want to say what it is in ergs, but I don't think I can convert that to normal people units, so I'm just going to skip that.
Well, luckily there's no normal people here. I'd like to, because I like pretty pictures, I'd like to help out Nicole here with a visualization that the folks over at Goddard Space Flight Center put together of what she's talking about, and it blew me away. I mean, I'm sure you've seen the animation, Nicole. And what I'm going to try to do here.
Can you screen share it?
Yeah, I can screen share it here.
This is the part where astronomy theorists make gorgeous, gorgeous movies of stuff we can't actually see.
All right, let's see if I can. Yeah, it's up.
Now I'm gonna play it. Now see that star whips around.
Whoa!
Sucked in.
And you see the time scale? That's over several days. Just several days, an entire sun just gets shredded.
I mean, this is just, and what you can just see the material getting dragged out. Now, Nicole, I'm not sure. I don't know what's happening to that long strand of material. Is that just going to be like kept in that gravitational pull? You can see the other stuff is just blowing. Okay.
I think it's actually escaping the system. So not all of that mass is falling into the black hole. That's just going to get kind of spit out into the interstellar medium.
That's just incredible. Really, really incredible. Okay.
That's fantastic. Thanks, Jason.
Sure thing.
All right. Well, why don't we move on to Sawyer? And I was going to go straight to Sawyer, but because Nicole needs to move on, we thought we'd give her a chance to exit when she needs to. But Sawyer, you've been like on the move, reporting on the wrapping up of the space shuttle. And did you get a chance to see the space shuttle, one of the space shuttles on top of the aircraft?
Thankfully, yes, I actually did. I got to see Enterprise when it came into New York City. But basically, we had everybody from Talking Space. We had us all scattered around at the Kennedy Space Center in Washington, D.C. and in New York to try and cover the entire event. So Mark Ratterman of ours, he was down at the Kennedy Space Center for about 8 days where he watched everything roll out, and he got to speak with some of the flow technicians and some of the astronauts. And that was really entertaining to hear their take on it. For example, they were saying that a lot of the workers down there, even though they knew that what they were doing was basically working on the end of the program and getting the shuttles out of there, they still had a surprisingly positive attitude towards it. And I'm not sure if this is the people that still have jobs or not afterwards, but they still had a very upbeat attitude towards it. So then that flew over to Washington, D.C., or more specifically, it flew around Washington, D.C., and then landed in Virginia at Dulles International Airport. And Discovery will be on display at the Udvar Hazy Center there. In fact, it actually is. So they landed, and they actually had a Discovery and Enterprise nose-to-nose, which was really an entertaining picture to see.
I saw the picture of that. Yeah, it was great. Jason?
Here's the one thing that I found really entertaining, though, is that to get the shuttle there, so basically, after it landed and they towed it over, so the tow driver for Discovery was a NASA employee. So he towed it all the way over. And then they stopped and detached. Then to get Discovery, even though he towed it off of that, to get Discovery from the ceremony actually into the Udvar Hazy Center, it had to be a tow driver from the Smithsonian. Because NASA at that point, after they signed the papers, released all liability from it, and it was turned over. So it actually took a couple of tries to get it into the hangar where it's going to be displayed. But then again, think about it.
Because they didn't have the experience, like the Smithsonian driver didn't have the experience that the NASA person. That's hilarious.
Yeah, the Enterprise hasn't moved much.
Right, it took them about 3 tries to get it in, 3 or 4 tries, and you're dealing with about 2 feet of clearance. That's it. So when you think about it that way, you're not dealing with much room here, and when you have someone that isn't as experienced as, say, a NASA person, who gets it into the OPF all the time, it's a little bit of a different story there. So,
yeah, I was
in safely.
I was there when they were doing that, and the tricky part is that when you're putting it into the Udvar Hazy Center, there's the garage door basically, and then they have a notch cut out of the garage door for the tail, and so you just kind of had to, it's like backing it in and taking it out, and like parallel parking a little bit, that you had to negotiate that corner. And in fact, when they were taking Enterprise out earlier in the day, they had to open up that door and open up the notch, and I guess they had to break some iron bars in order to get that notch open because it had been closed for so long. So a lot of unanticipated little tricks that you run into when you're trying to take a 90-ton spaceship out of the garage.
Bottom line, that's not going anywhere now.
No,
right.
That's in there pretty good for now, but at least it's in. And for their 14 of Discovery's, I believe it's 31 remaining commanders who were alive were at the event, so that was pretty neat to see as well. So then after that, after a bunch of weather delays, it was supposed to originally be on that previous Friday beforehand, I believe, or actually, Monday the 23rd. And then it was delayed to the 25th, and then finally it actually happened on Friday the 27th, where it took off from Dulles, and then it made the 45-minute or so trip over to New York, where it did a nice fly around to the city. It flew by the Freedom Towers, flew over the Statue of Liberty. In fact, it made a pretty big loop. It went all the way up into New York State by Westchester County, and then came all the way back around, and it did a nice little flyover of the runway. Now, the interesting part for me is I was in the grandstand with a majority of, some of the media and a majority of the invited guests. So as it's coming in, we're waiting for it to land. And then all of a sudden we see a taxiing. We're like, wait a minute, we missed landing. What happened? Turns out because of wind, they ended up changing the runway, and boy, it was windy that day.
Yeah. Did anyone see that video? There was like someone had a video on YouTube where they were on the airplane that was right there when the space shuttle landed right beside them. Oh, what a moment. But still, I mean, you were there and you got to see it, so I'm super jealous.
That was a heck of a video there you're talking about, but yeah, it was great, and it was nice also to see, because for those who don't know, the Space Shuttle Enterprise was originally named Space Shuttle Constitution, because it was rolled out in 1976, you know, the 200-year anniversary of the United States. And so there was a write-in campaign led primarily by Gerald Ford and Star Trek fans who decided to write in and rename it the Space Shuttle Enterprise, and obviously it won because that's the new name of it. I say new, we're talking about the 1970s here, but the entire crew, the entire cast basically of Star Trek was there in 1976 when it first rolled out in Palmdale, California. And Leonard Nimoy, Mr. Spock himself, was there again in New York City to see it as it went to the Intrepid Sea Air and Space Museum, and so he gave it his famous "Live Long and Prosper." And so,
fantastic. All right, well, let's move on. Jason,
yes.
You want to talk about a new mission to Jupiter?
Yes, very exciting. Well, yesterday, the European Space Agency announced that they approved a mission to Jupiter that will investigate its icy moons. Now, the name of the mission is JUICE, J-U-I-C-E, and that stands for Jupiter's Icy Moons Exploration. Now, it's kind of weird because the J and the U come from Jupiter, and the I and the C are ice. Moons gets ignored, so there's no M in there, and then the E comes
Can't spell juice without U, I guess, yeah.
And so it's a little weird like that. But regardless of its name, it's going to be the first dedicated exploration of the Jupiter, of the Jovian system, since Galileo back in the mid-90s. And it will also be, well, I mean, I'm not discounting Juno, because Juno is going to investigate primarily Jupiter's atmosphere, whereas JUICE is going to check out the moons, especially the 3 moons that they believe have a water ocean, a liquid water ocean underneath their surface, which will be Callisto, Ganymede, and Europa. So it's going to launch in 2022, I believe, and it's going to it'll have a 7.5 year cruise to Jupiter, and will arrive at the Jovian system in 2030. It's going to head for Callisto. It's going to do some. It's going to check out Callisto's surfaces. Callisto's surface is one of the oldest and most created surfaces in the entire solar system, and it's believed that it may have a liquid ocean underneath its surface. So it's going to check out Callisto. Then it's going to head on over, do a couple of passes of Europa. Everyone, knows Europa. It's one of the smoothest and icy. It has a very, very smooth, icy surface, covered in cracks, very few craters. Really, really good chance that there's an ocean underneath that surface, and probably not too far down. Although they're not 100% sure, they're still investigating that, and that's what JUICE is going to help out with. And then from Europa, it's going to head over to Ganymede, the largest of the Jovian moons, the largest moon in the solar system. It's actually 8% bigger than Mercury. So, I mean, this is a really, really big moon. Like Callisto, also very, very cratered, very old surface, and also probably has a liquid ocean underneath, as well as a liquid molten metal core, like Earth's, that gives it a magnetosphere. One of the only moons, I think it actually is the only moon in the solar system to generate a strong, powerful magnetosphere, which it needs sitting in the middle of the Jovian system. Jupiter has a really, really powerful magnetosphere itself. So they're going to investigate with JUICE how all of that works, what's happening on the surface, what's happening underneath the surface, and how the magnetosphere of Ganymede works in the Jovian system. So it's
now, is
really,
it going to
really
be doing flybys of the moons, or is it actually going to be doing orbits?
Well, there's going to be orbits around Callisto when it starts off in 2030, when it gets there. Then it's going to do a couple flybys of Europa. Now, I don't think it's going to actually establish orbit there, and then head over and spend some time at Ganymede. So it will orbit Ganymede. And it's also going to check out Jupiter's upper atmosphere as well, looking for aurora and investigating the magnetosphere of this huge gas giant that's really kind of the dominating force in our solar system. So that's why investigating Jupiter is so important. In addition to that, a lot of the exoplanets that they find around other stars are Jupiter-like. So there's a good chance that they also have moons, a varied family of moons just like Jupiter does. It may have moons with oceans inside of them. So looking at Jupiter and looking at the Jovian system is really kind of like getting a sense of what's out there in the galaxy.
Now, Emily, do you have a hand in this in any way?
No, I'm afraid we do not, but I'll certainly be happy to see it arrive at Jupiter. It's been a long time since we've had some really good high-resolution close-up views of Jupiter's moons.
No, but this, I mean, the mission profile sounds very similar to a lot of the missions that had been on the books from NASA for several years and just had gotten canceled. So it's kind of strange that, or maybe not strange, it's nice that ESA's picked up the reins and is planning to take this mission to completion.
Well, it's no coincidence actually, because this was originally one half of a joint NASA-ESA mission. It was supposed to be 2 orbiters, one built by NASA to orbit Europa, one built by Europe to orbit Ganymede, and they were going to be in tandem, launched at the same time and arriving at Jupiter at the same time to do combined studies. The United States withdrew from that. This is even before it withdrew from ExoMars, so it's twice that they've slapped Europe in the face. And Europe decided to go on. They actually recovered some of the science objectives that were supposed to be accomplished by the American Europa mission and added those to JUICE, which is, I think, probably one of the things that pushed this one over the other 2 more astrophysics-type missions.
Yeah, and this isn't the first time this kind of thing has happened. It's great to see Europe just continue on with the mission. I mean, there's all the stuff that's been going on with the ExoMars and with the Mars sample return missions and things like that. So
this is Europe's. I believe this is Europe's first foray out into the outer solar system with a dedicated planetary mission like this.
Unless you count Rosetta.
For an asteroid, yeah.
Yeah.
Yeah. No, that's good. I guess we'll be watching that one very carefully. All right. Well, Ian, I'm going to put you on the spot, and you want to talk about, well, you talked a bit about the asteroids, which was great, but you also had a great story on brown dwarfs this week.
Oh, yeah, brown dwarfs. Brown dwarfs, they often get a bad rap. I often find that certainly press releases will refer to them as like failed stars.
Stars, yeah.
Yeah, you're a failure, you're a stellar failure. Or sub-stars, I think was an older term for them. So basically they're failed stars, as in they could be stars, but they don't have enough mass to sustain fusion in their cores. A few of the larger ones, they can do very short periods of fusion, I think it's with deuterium and lithium. But all intents and purposes, they're like really, really, really fat gas giants. And they form a fascinating bridge between what can be considered a planet and what can be considered a star. So I actually find them more interesting than just a failed star. I actually think they're an overachieving planet. I mean, I'm more positive when it comes to brown dwarf studies.
Supermassive planet.
Yeah, supermassive planet. You know, why is everybody so motivated to call, big black holes, supermassive when we can call these supermassive planets? But yeah, the most recent fascinating study, and the thing is, because they're very difficult to see as well, because they're often floating alone by themselves in interstellar space. So they're very difficult to spot because, of course, they're not emitting in visible light. So often missions like WISE, the Wide Field Infrared Explorer by NASA, those kind of missions can spot an infrared emitting brown dwarf. But in optical light, you can't really see them. But most recent study, it was carried out by Penn State University researchers. They used the Arecibo telescope in Puerto Rico to detect radio emissions from the magnetosphere of a brown dwarf. Now, of course, planets, like the Earth, we've got this global magnetic field that ultimately protects us from the worst radiation the sun can throw at us. And so in this case, with this brown dwarf, it was emitting radio waves. Now, that's kind of an oddity because you need charged particles basically to be traveling around a magnetic field within the atmosphere of this brown dwarf. And the big mystery was, with this particular brown dwarf, it's called J1047+21, very memorable name there. It's about 30 light years from Earth, I think. And basically, they detected these emissions coming from this failed star, and there were flaring emissions of radio waves. And basically, the researchers postulate, they think that what's happening, this brown dwarf has quite a strong magnetic field surrounding it, and deep within the brown dwarf's atmosphere, reconnections occurring. So basically, these magnetic field lines are being forced together somehow deep within the brown dwarf, and they're reattaching, snapping, very similar to what happens with our sun. Remember, these brown dwarfs have got some characteristics of stars. But with our star, basically you get reconnection at the surface of the sun, deep in the corona, and that can create coronal mass ejections and solar flares. So these are very violent events. But in this brown dwarf, what they think is happening, this reconnection event is happening deep inside the brown dwarf, and it's sending a bubble of highly charged plasma through the surface, and it's exploding into the atmosphere of the brown dwarf. And that's sending electrons spiraling around the magnetic field. And that is what's generating these amazing, this basic new way of detecting brown dwarfs. It's generating these radio waves.
And so they don't have to look for an infrared signature from these things. They can actually now pick them up with these incredibly powerful radio telescopes that can join together and make monster telescopes.
Exactly, yeah. And I don't think it's going to be a primary method to detect these objects, because missions like WISE can spot the infrared radiation of these objects. But there's very, very cool objects out there. Some of these have got surface temperatures of room temperature. I think that's the record breaker of an ultra cool brown dwarf, and they're just fascinating things to study. And also, this had a lead-in then to, and I found it, the whole hook of this press release from Penn State was this can actually help us find magnetospheres surrounding large planets. So not only are we detecting these radio waves coming from a brown dwarf, we could perhaps detect this kind of plasma interaction with the magnetospheres of large planets. And because we are basically detecting the radio waves coming from a magnetosphere on these exoplanets, perhaps this magnetosphere actually protects a biosphere, protects an alien biosphere on these worlds. So suddenly we got a method of detecting worlds with magnetospheres that could ultimately protect life that it may actually be nurturing deep underneath its atmosphere. So it kind of has some tie-ins, and I just find these enigmatic objects really, really fascinating, because they not only form an amazing bridge between what can be considered a planet and what could be considered a star, but also this particular failed star is actually helping us with finding worlds that could support life, and I just find that fascinating.
Yeah, you've been able to bring everything into this story.
I tried.
Except for even detecting aliens.
Except for asteroid mining. There's no asteroids involved in the making of that story.
Yeah.
Well, they're left over from making planets, so they're assumed.
They're in there.
So Nicole, I mean, you're the radio astronomer in the group here. How does that sound to you as a method of detecting exoplanets? Well,
I was actually going to ask Ian, are these like a time variable flares, or is it a steady emission? Because if it's time variable, there's these big radio telescopes that are being built to monitor the whole sky.
Apparently so, yeah. These are flaring events, and the lead, because I actually got in touch with the lead researcher on this work, and he was saying the most fascinating thing about this research was that you're getting this reconnection event deep within the brown dwarf, and that's producing a bubble of plasma which is erupting to the surface. So the time variability comes from these eruptions from the surface that releases. It's like letting gas. It's releasing these electrons to the magnetosphere, which then spin and produce the radio waves. So that was pretty cool. I thought
do those electrons can they tell what the composition then of the brown dwarf or of that atmosphere is?
Yeah, they are able to gauge the surface temperature of this particular brown dwarf, and apparently they detected it at 5 times the temperature of Jupiter's atmosphere, and I think that was like 900 Kelvin or something. I'm not entirely sure of the numbers, but I'm not entirely sure how they got that information. I assume that it's just a consequence of the emissions, and they got that information from the radio wave emissions. So yeah, they can gain a lot of information from it. As for the composition of the atmosphere, I don't know. I can't.
But this really does sound like a whole new method of detection and analysis. of a class of objects that's very, very difficult to get any information about. So this is actually really, we started with boring brown dwarves, and now you've got us excited about the detection of supermassive planets with biospheres. So nicely done, Ian.
Brown dwarves.
So Emily, why don't we close with your coverage of the last flybys of Enceladus?
Yeah, actually, this is interesting because I didn't see the images by last night. The flyby happened yesterday, and the images didn't come down last night. They just came down this morning. In fact, it was so recent that none of the guys in unmanned spaceflight has apparently had time to process and post images. So I thought what would be kind of fun is if I show you where I go in order to get these images in the first place.
So is this a world exclusive? No public relations have had a chance to massage this, so we might see alien structures.
Yeah, that's right. Ironically, the public relations people can't get the images out as fast as the amateurs can. So I'm going to share my screen, and I've got to find the one. Here it is. Okay. So is that working? Yes. Okay, so this is the Cassini mission homepage. And where I go and I know that there is a flyby happening is you go to the images menu and you select raw images. And when they say raw images, they're talking about images that are pretty much fresh from the spacecraft without any processing applied. And then there's an arrow here that says Browse Latest 500, and I always click that, and whoa, there you go.
Oh, new
so
one.
What you have here are some data fresh from Saturn. Not very many people in the world have actually had a chance to look at this stuff yet. And what you're looking at are pictures of one of Saturn's icy moons, Dione. If I look up, I'm looking at a poster that I have behind my computer. I think it's like the 5th largest moon of Saturn. And some of these pictures, here we see part of Dione against black sky, but up here we're actually seeing Dione against the backdrop of Saturn itself. Now, all of these pictures are black and white because Cassini's camera is a black and white camera, and the way that it gets color pictures is by taking multiple images of the same spot through different color filters. And so you can see here, like for instance down here, we have 4 views of sort of a corner of Dione against Saturn, and you can see the shadow of Saturn's rings crossing some of these. I'll enlarge this one so you can see it. So this is a shadow of Saturn's rings, and this is Dione right here. And you can see that there's 4 of the same photo, and I can tell you without even looking at it that this one right here was taken through a blue filter. And the reason that I know that is because Saturn is yellow, hence it's very dark at blue wavelengths. So you can see how dark Saturn is compared to Dione, which is a white icy moon. So I know that this one was taken through a blue filter, actually probably an ultraviolet. Yes, ultraviolet filter. And so this is where I go when I get data fresh from Saturn. You can see that the spacecraft is close enough to Dione that it had to take numerous images in order to cover the globe. So it's like a puzzle. You have to put it together to make a pretty global, high-resolution picture of Dione. Here looks like there's some great pictures of the limb and terminator of Dione against Saturn. You can just keep on going and see all of these absolutely fresh images straight from Saturn. And before Cassini flew past Dione, it also flew past Enceladus. What's this one? This is still Dione. So
there's a lot of great shots of Dione here. Holy smokes. I know what I'm going to be doing this afternoon.
Yeah, there really are. And then, so this is the end of the Dione flyby, and now we see these. And these are Enceladus's geysers shot against the black background of space. With the sun is nearly in front of the spacecraft, so it's shining through the geysers, and you can see the geysers shooting off into space. They took a lot of pictures of that. Here's a lovely view of all of Enceladus, a beautiful crescent view of Enceladus, and you can just barely make out the geysers up here. Probably those of you watching at home can't see it, but if you go to Cassini's website, you can see them. So this is where I go when I shop for new images of Saturn that nobody's ever seen before. And that's undoubtedly going to be the topic of a blog post from me later today, as some of the pretty pictures from the tandem Enceladus and Dione flybys. The sad news for those of us who are fans of icy moons is that this is pretty much the last one of Cassini's close moon flybys, other than flybys of Titan, for quite a while, for about a year. because Cassini's been in the ring plane for a long time. It's orbiting in the same plane as Saturn's rings, which means that it gets lots of happenstance close encounters with the moons because they also orbit in the same plane as the rings. But with a Titan flyby at the end of this month, they're going to tilt the orbit again so that they can look up and down onto the rings, but that makes it much less likely that they're going to have close flybys by any other moon except Titan. They always come back to Titan because they use Titan for gravity assist to change the orbit around Saturn. But anyway, I thought it would be fun to just take a tour of some brand new, fresh images from Saturn.
Well, and it was great to see the method because I don't think a lot of people realize exactly how you're able to find those stories. Because, I mean, the rest of us all are always amazed at how quickly you get those stories and how you process them, and they look great, and you do this great analysis, and you create these puzzles. And, you know, most of us just wait for the NASA folks to get that together, but you jump the gun and jump the queue and get that all organized, and it's great. And so now I hope Jason's been taking notes for his story.
I just made a picture of I grabbed some of the initial shots that Emily was showing of Dione against, you know, the one with the blue, taken in the blue filter.
Oh, and you actually like composed it and
I just made a composition. If you want to check it out.
Yeah, can you screen share it? That's awesome.
Yeah, let me see. Screen share. Where is my? Here it is. Oh no.
Yeah,
that's funny.
Windows open.
That's funny. It only
If you can scroll down if you have a lot of windows open.
Maybe I'll do this one. My desktop. Okay. And I'll do this, and that way you can hopefully
Turtles
see
all the way down.
There you go.
Can you see the can you see the image?
Yeah, that looks great.
So what that is like she said, it was taken. It wasn't taken in the red, green, and blue wavelengths. It was actually taken in the infrared, green, and ultraviolet. So it's not quite what the human eye would see, but you can see you can see the color cast, or at least the color differentiation on Dione, and then in the background you're looking at basically the cloud tops of Saturn, again in that slightly expanded color range.
And it looks like there's like a storm on Saturn there. Maybe it's on my mind.
I mean, I can, if I take this and kind of crank the levels a bit, you can see, there's something right in there. You know,
you have to be careful with interpretation of faint features in the raw images because there's several things that make them not as pretty as the archive data. For one thing, all of these things have had their contrast stretched to occupy the entire available histogram of different pixel values. So they're stretched so that the brightest pixel is always white and the darkest pixel is always black, which it means that it's very hard to get the colors to be exactly correct. So for people like Jason and me, we do a lot of fudging when it comes to the colors to make them look like we think they should look.
Which makes people very angry sometimes. They demand I like the term unadulterated images. Don't touch these things because that means that we're obviously hiding something, and I'm not going to bring that whole event back up.
Another thing that a lot of these images have is a lot of cosmic ray hits. Where energetic particles have come in and hit the detector. This particularly tends to happen when you're close enough to Saturn to be within its magnetic field, or when you've had a very long exposure. And ultraviolet images require very long exposures because there's not very many photons at that wavelength. So ultraviolet images tend to have a lot of cosmic ray hits. There's also just things like dust on the Cassini's lenses, and those make these donut features, they show up especially on Saturn itself because Saturn is so flat and smooth it's very easy to see the donuts. And those are just out of focus views of bits of dust on the detector. So in order to make these things pretty, the amateurs like me and Jason do a lot of sort of painting and processing to get rid of these blemishes and make them show the beauty that they can. But of course, this makes them very unsuitable for science, and you have to always put that caveat in the kinds of pictures that we produce.
So we just discovered some kind of alien space station floating in Saturn's atmosphere, and you're already going into denial mode.
I'm just whitewashing it. I'm painting it.
You're whitewashing it in real time.
Kittens in space.
So let's just a couple of questions. We actually don't have a mountain of questions, so I thought I would just quickly do them. Jonas Cain suggests that we call these stanets as opposed to failed, brown dwarfs. We call them stanets, I guess, star-like planets. I like that.
Okay with that.
Stanet, yeah. Or planemos. Alan, you were saying planemos, right?
Yeah. Planetary mass objects.
Jonas also wants to remind everyone that there's going to be an eclipse coming up on the 20th.
The annular?
Yeah, it's an annular eclipse, right?
Mm-hmm.
Yes.
I think it's only visible in a like a 200 what was it, a 200-mile wide swath that runs across the southwestern U.S.
And the Northwest, the Oregon-California border, and that's where I'm going to be on the 20th. So I hope for clear skies.
How wide will the partial eclipse be?
Oh, the partial eclipse will be visible over a pretty wide area of the western United States. Because of the timing, it'll be sunset in the east, fairly soon. So that's not going to get in on a whole lot of the partial phase of the eclipse. But
yeah, it'll be visible down to LA.
Yeah.
And how far north? And by that I mean
Greenland?
west coast of Canada. Okay. All
Yeah.
right. Yeah. So we can see something. Yeah. Okay,
Oh,
great.
definitely. Mm-hmm.
Okay, great. A lot of people were, well, Nicole's gone, but a lot of people were congratulating her on her doctorness. And I don't know if everyone saw, Nicole had some eclipse glasses on, ready to go for either viewing the transit or the eclipse.
Yeah, there's the Astronomers Without Borders has a deal with telescope supply provider to make eclipse glasses available. So I wrote a couple of stories about the upcoming eclipse over the past couple of days. So if you go to cosmiclog.com, you can catch up with those stories and get your solar viewing glasses, which you can use for the eclipse as well as for the transit of Venus. Although you're not going to see, you're not going to get a great view of the transit of Venus unless you use binoculars or a telescope, and you want to make sure you use it the right way. Yeah. Never look at this. Never look at the sun unless you have the appropriate protection, and you can find all sorts of information about that on the web.
And I'm assuming, Alan, that you shouldn't put the glasses on and then look through a regular unfiltered telescope or binoculars, because then they would be very dangerous still.
Good assumption that if you're going to put a filter on a magnifying device, you put it in front of that first lens or mirror.
Yeah, ouch. Okay, great. Well, I think actually we don't have a lot of questions this week, so if anyone has any questions, you can save them for next week. So I want to thank everybody for showing up for this new and improved Weekly Space Hangout, and thanks again to all of the new folks who've joined us. Thanks to Amy and to Sawyer and to Jason, who are here with us next week. It was great to have you guys, who were awesome, and I'm sure you'll see some great feedback from everyone. So fantastic work. And thanks again to all of the regular participants. Thanks Alan and Emily and Ian and Jason. It was great to have you guys here, and thanks to Cole, who's gone. Now we're going to be possibly recording a impromptu astronomy cast tomorrow. I think we might have it in the calendar. I'm not sure the time. We're going to be talking about lasers and masers, so we're going to be talking about that tomorrow, just as we've got some shows to catch up, so we're doing that. And then, of course, we're going to be doing the virtual star party on Sunday, so we'll be hooking up a bunch of telescopes, and whenever it gets dark, and we'll see what we can see. So if you want to attend any of these events, the best place to find out is to go to cosmoquest.org. We've got a calendar of all the events that are happening there. You can, as well as you can sign up to join CosmoQuest and help us classify craters on the moon. And while you're there, you can sign up for a newsletter that will come into your email box and sort of let you know what the schedule is for the week. So thanks for everyone who's watching. Thanks to everyone who joined us, and we'll see all of you next week here on Google+.
Oh, Fraser, 1 second. Can I just give a quick shout out to Caustic Soda, your friend Torin? I was on his show, I think it was last week. It was about the sun, how it can be a doomsday device. It was a great show. I'm wearing a T-shirt.
Yep, I've got one too.
Yep. So go to iTunes and download the latest podcast, because I think it was awesome. I had a great time.
You know, and why don't we, while we're doing this, I just want to get people to know where they can find out more about everybody. So Sawyer, where can people find out more of what you're doing?
People can find more about Talking Space and what we do at talkingspaceonline.com is our website, and again, you can also download us on iTunes.
Perfect. And you guys do, how often do you record?
Our show is weekly. We usually record on a Monday, and it comes out every Wednesday, usually within the 4 or 5 o'clock hour on our website. and then iTunes whenever it decides to post it.
Fantastic. And Jason, you are lightsinthedark.com?
I'm at lightsinthedark.com. Of course, I also write a ton of stuff for Universe Today. On occasion, I'm writing things for Ian over at Discovery News. Every now and then, I'll have an article up on National Geographic News. And then, of course, I'm always, over the course of the day, tweeting at JP Major. And then I've got a Facebook page. I'm on Google Plus, and there's always something.
And Ian, of course, discovery.com/space.
Yeah, you can go to discoverynews.com. That's probably the easiest way to get there.
Discoverynews.com. Yeah.
Discoverynews.com or astroengine.com. Yeah, Astro Engine on Twitter. Yeah, you'll find them.
And Emily, you're at planetary.org. That's it.
Planetary.org/blog.
Yeah, right. And Amy, vintagespace.com. Did I get that right?
.wordpress.com.
Vintagespace.wordpress.com. That's right.
Haven't bought my domain yet.
You should buy your domain.
and Google Plus and Twitter and Facebook. So I'm around.
Yeah, great. And Alan, you're...
Sure. It's cosmiclog.com. That's an easy way to get to my blog. And then there's a lot of stuff on space.msnbc.com. That's kind of a little secret short URL, so now you're in on the secret.
Perfect. All right. And, of course, I'm at universetoday.com and astronomycast.com and right here on Google+. So thanks again, everybody, and we'll see you all next week.
Bye-bye.